Hi guys, this is Mrs. Rooker, and I'm going to be doing Law of Science Ambiguous case with you guys. You should have already done a little bit of this in the last video, but I'm just going to kind of go into it some more. Alright, so the first question, how is it that two triangles can result when given two sides at an opposite angle? So I'm going to draw a picture for this one. So let's say we have two sides. Here, I'll do a better drawing. So we've got a side and a side. Let's call this 10, and we'll call this 8. And we'll say this is 30 degrees. All right, so that's one way that the triangle could be drawn, and that could have a side of 8, another side of 10, and an angle of 30. But the other way it could be drawn is we could take this angle up here and we could hinge it at that angle, and instead of having the 8 come out like it does there, we can have that side come inward and still be 8, but instead create a triangle that's actually appears to be an obtuse triangle, an obtuse angle right here. So that's two different ways, even though we have two sides and an angle there. And the reason here is because what we have there is side-side angle. You remember angle, side, angle, side, angle, angle, side, and side, side, side from geometry. Well, remember side, side, angle, or you might remember it written the other way around, was not one that we are allowed, to use in triangle congruence proofs, because ASS or SSA does not give us one unique triangle. It can actually give us two different triangles. All right, and then the second part of the question said write down the relationship that exists between the opposite side, the height, and the adjacent side. So what I did was I wrote this down ahead of time, and I would like you to pause the video and write all this down. This is going to be really important. We're going to refer back to this, and this will help you whenever you're doing the ambiguous case. I want you to focus a lot on this third one right here. If the opposite side ends up being greater than the height, and it's also less than the adjacent side, then it's going to give us two triangles. All right, so write all that down, and then we will get started on the first example, and we'll kind of refer back to what I have written up there. I'll explain it a little bit more, each problem. All right, so the first thing you're always going to want to do is draw a diagram. I try to draw my diagrams pretty similar every time, just to be consistent. So I usually draw my angle in this corner. Sorry. So this will be 56 degrees. And then if this angle is big A, little a is always opposite of that, just a reminder. So little a is going to be opposite of big A, so that's going to be 10. And then B, it doesn't matter which one B is, but I'm going to put B right here. If this is B, then this will be uppercase B, leaving this to be uppercase C and lowercase c. That's A. All right, although I don't get too hung up on A's and B's and all of that stuff, because A and B aren't always in the same place on every triangle, and we're not always given the A. Sometimes we're given the B or the C or whatever. So I don't call them A, B, I call them opposite or adjacent. And we're always comparing to the angle. So if this is the angle, the 10 would be considered the opposite. So this is opposite side, and then the 12 would be adjacent side. And the first thing I always want you to do is compare the opposite to the adjacent. When we have an acute angle that we're dealing with, if the opposite is greater than the adjacent, if you look over here, if the opposite was greater than the adjacent, then we would have one triangle, and we wouldn't have to then go and find the height. But the opposite isn't greater than the adjacent. The opposite was less than the adjacent. So since the opposite is less than the adjacent, what we want to do is also compare the opposite to the height to determine if it maybe fits the requirements for this one. So that's what we're going to do now, is find the height. And, oops, I had done this earlier, but I'll do it again. Here is the formula for finding the height. Height is going to be, and if you don't have this written down somewhere, make sure to write it down. Height is going to be adjacent, adjacent sine angle. So on our triangle, the adjacent side is 12, sine, and the angle we have is 56. Type that into your calculator and you'll get that h equals 9.95. Be careful, make sure your angle or your calculator is in degree mode when you do that. Alright, so we get that the height is 9.95. Which is less than that opposite side. So the opposite was greater than the hypotenuse. So let's look back at our list. The opposite was greater than the hypotenuse, but also less than the adjacent, which means we are going to have two different triangles here, which means double the work for us. We're going to have to find all the sides for one triangle and then use some of that information to find all the sides and angles for the other triangle. So let's get started. We'll use law of sines. Remember, sine is sine of angle, so the angle we have is 56, over opposite side, which is 10, equals sine of angle, we don't know any other angles, which will be, over opposite side, 12. And I chose to use angle B next because I did have that opposite side. Alright, we solve by cross multiplying. 12 sine 56 equals 10 sine B. And then I'm going to divide both sides by 10 to get rid of the 10 on that side. And then lastly, I need to get rid of the sine in front of B, so I'm going to do inverse sine both sides. This whole thing I need to do inverse sine of. But I think it's going to be easiest if I just type in 12 sine 56 over 10 first. And then do inverse sine of that. I think it's easier. I won't mess up as easily. Inverse sine of that answer. So I get that angle B is going to be 54.2-ish. Whoa, not 54. 84.2-ish. Sorry, guys. Degrees. So that's going to be this angle here. And the next thing I'm going to do is once I have two angles, I can easily find the third angle by just subtracting from 180. So I'm going to do 180 minus 56 minus the 84.2 that I had. And I get 39.8-ish. So that's going to be angle C is 39.8 degrees. The only thing that's missing is I need to find side C. So I'm going to use law of sines again to find little c. I'm going to use this sine 56 over 10 again. But I'm now going to set that equal to sine of angle C, which was 39.8. over little c. Again, cross multiply. C sine 56 equals 10 sine 39.8. Divide both sides by sine 56. And that will get rid of the sine 56 or after the c. Type all that into your calculator. So 10 sine 39.8. Divide that by sine 56. And we get that little c equals about 7.7. It's always good to just kind of double check and make sure your measurements make sense on that triangle, and they appear to. So all good. So that was one triangle, but remember we can have two triangles, and I forgot to actually kind of draw and show you why that was the case. So we've got this 10 and we kind of drew it out like this, and we drew it as like an acute triangle. But because this 10 is longer than the height, but it's shorter than the adjacent side, what could happen is that 10, instead of being out like that, it could hinge inward and create kind of an obtuse triangle. So what that angle is going to look like, or that triangle, we've got the 56, and then the 10 is actually hinging inward and giving us, this would be 12, this will be 10, and then we've got a big obtuse angle right there that we're trying to find. That's our new B value that we're trying to find. The way to find the new B value, which we call B prime, is we do B prime is going to equal 180 minus B. So type into our calculators. We know B was, I don't know what our B was, 84.2. So the original B that we got was 84.2. So we can use that to find B prime is going to be 95.8. And now that we know that information, we can use that to find C and then C prime. So to find, or sorry, C prime and then little c. Remember, all the angles in a triangle need to add to 180. So we've got 56. We've got 95.8. So 180 minus 56 minus 95.8. It's going to leave us with 28.2 is what C prime is going to be. Should be putting my degree symbols on there. There we go. And now lastly, we need to find little c prime. And we're going to have to use law of sines for this. So I'm going to do sine of 56 over 10, because that's sine of angle over opposite side, equals sine of angle, which is 28.2, over opposite side. So that's going to be little c prime. Cross multiply, c prime sine 56 equals 10 sine 28.2, and to get c prime by itself, we just divide by sine 56. Type all that into our calculator. 10 sine 28.2 divide that by sine 56. Oops, sine 56. And I got we'll just call that 5.7. And hopefully that makes sense based on our little diagram that this is going to be smaller than it was in the other triangle. All right. That is it for that problem. Go ahead and pause if you need to catch up on any of it. Lots of writing. All right, so moving on to the next one, we're given a triangle and we need to solve for AB. So we're trying to find that base. First thing I want to do is compare the opposite with the adjacent side. And I noticed that opposite is less than adjacent. So I could have two triangles. So what I need to now do is compare to the height. So to find height, I'm going to do H equals adjacent sine angle. So height is going to be adjacent side, which is 63, sine angle, which is 37 degrees. Put that into my calculator. So 63 sine 37. And I got 37.8, about 30 or sorry, 37.9. We'll call that about 38 is the height, and the height would be drawn like this down to the opposite base, and that's going to be about 38. So the opposite was less than the adjacent, but the opposite was greater than the height, which means we are going to have two triangles that could happen here. So we've got one drawn here, and what the other one is going to look like is we can swing this side outward. It's still going to be 50, but it's going to be a really long AB. So we're going to use law of sines twice to find that side. So the first thing I want to do is sine of 37 over opposite side, which is 50, because that's the side that I have. And then I'm going to use that to find angle B, because I have side B, so I can use that. So sine of B over 63. And then we're going to cross multiply to solve that. 63 sine 37 equals 50 sine B. Divide both sides by 50 to get rid of the 50 there. And then do inverse sine to get rid of the sine in front of B. I'm going to type into my calculator. I'm going to do the 63 sine 37 over 50 first. Divided by 50, and then do inverse sine of that. Alright, so B equals, I keep doing that, keep clicking before I actually look and see what B was. B was 49.3, but that's not what we actually wanted. We want this side here, but we can only find that if we know that opposite angle. Now that we know angle B, we can use that to find what angle C is going to be. So I'll do 180 minus the 37, so that was our first angle, minus the angle we just found. And that's going to leave us with 93.7 for angle C. Clearly we're talking about the big triangle, and we're talking about those angles that we got just now. So we're going to get the bigger side on this round. Alright, so now that we have that, we'll use law of sines again to find this opposite side. So sine 37 over 50 equals sine of the angle we just got, so 93.7, over, I'll just call that little c. Cross multiply, little c sine 37 equals 50 sine 93.7. Divide both sides by sine 37. Type that into our calculators. 50 sine 93.7. Divide that by sine 37. And we get 82.9. So little c, or I guess that was technically called AB, was 82.9. Alright, so that was just the first time. Now we have to find it for our second triangle. So what we need to do is go back to this first B that we found. And clearly, this wouldn't be drawn to scale if this was 49.3. The 49.3 should really be probably this angle. So we're going to find this angle, subtract 49.3 from 180. And that will be the actual angle B that we. So we now get that the B that we want to use, which is technically our B prime here, is going to be 130.7. And that's what we're going to use to now find this actual smaller AB over here. So once we have B prime, we can find C prime by subtracting from 180. I'm just going to do this on my other calculator because it's quicker. 180 minus 30.7 minus 37 gives us the, oops, 180, I said it was quicker and then I messed up. Minus 37 minus 130.7 gives us that C prime is going to be 12.3. Now that's what we can use to do law of sines one final time. Sine 37 over opposite side, which is 50, equals sine of 12.3 over little c prime. Cross multiply, little c prime sine 37 equals 50 sine 12.3. Divide both sides by sine 37. So 50 sine 12.3 divided by sine 37 gives us 17.7. So little c prime equals 17.7, which is likely the side that they were asking for right here. I don't like to assume that they're talking about, or that the triangle is drawn to scale. It's a habit from, I used to be a formal geometry teacher, so we don't want to assume, so that's why I found both of them. But likely what they're actually looking for there as an answer would be 17.7 and not 82.9. So AB could be either of those, but based on the diagram, this seems much more realistic. All right. Oops. Okay. Decide whether each of the following will result in two triangles. We must always find the height first when we are given SSA and the angle is acute. So find the height first, and you're going to do some comparisons to decide if you have one triangle, two triangles, or no triangle. So for each one of these, I'm going to draw a diagram first. All right, so for this one, we have an 89-degree angle, which is almost a right angle. And then the opposite side is just 4, and the adjacent side is 9, which is a little bit weird. If this is only 4, I don't know that that's actually even going to reach the other side. So to me, that's a little bit of a red flag that I might not have any triangle at all. But we're going to compare the opposite compared to the adjacent. Opposite is less than the adjacent. Let's also compare the opposite to the hypotenuse. So, or not the hypotenuse, the height, sorry. So height is going to be adjacent, sine, angle. So height is going to be adjacent, which is 89. Nope. Adjacent is 9, sine, angle, which is 89. So we'll type that into our calculator. 9 sine 89 gives me the height is going to be 8.99. So the opposite is less than the height as well. And if we go and we look at our list, if the opposite is less than the height, we have no triangle at all. So that's our answer for that one. No triangle. All right, I'm having some issues with my pen, so hopefully it'll work here. This next example, we want to be a little careful because they actually gave us angle B this time and not angle A. So I'm actually going to put B here. Sorry, it's kind of glitchy. Okay, well, it keeps disappearing on me, but B should be right there. And that should be 78 degrees. And then opposite of that will be the 14.2. So this will be our 14.2. And then, that's really annoying, it keeps glitching, I'm sorry. And then our A is going to be over here. So it's all just kind of backward from what we had before. All right, so now we're going to do some comparing. The opposite is 14.2. Opposite is greater than the adjacent, which is 11. Sorry, that's going to be really hard for you guys to follow. But opposite is greater than adjacent. So let's go look at our list. If opposite is greater than adjacent, that's one triangle automatically. So we have one triangle. All right. I want you guys to pause the video and try the next one on your own. Actually, why don't you try the next two on your own and then unpause the video and I'll have the answers up there for you. All right, so on these ones, we actually have the exact same thing that we had going on example number 2. The opposite was greater than the adjacent on all of these. And we're only going to get one triangle if that happens. And that's because if this opposite side is larger than the adjacent side, it can't hinge inward. Otherwise it's going to pass that 19 degrees. So it can't hinge inward and create another triangle. So we're just going to have one triangle for all of those examples. All right, so now let's move on to the last one. It's going to be a tricky one, so I'm going to have you do some parts of this on your own, but I'll do some of it with you. So we have angle A is 48 degrees. I'm going to try to draw this to scale, kind of. And then the opposite side is going to be 6. That's 6. And then my other side, my adjacent side, is going to be 7. So that's opposite and adjacent. And remember, I know that that's the opposite side because it's opposite big A. All right, so first thing I need to do is compare. I see that the opposite is less than the adjacent, which means if we look at our thing, opposite is less than adjacent isn't one of the things I have on here. So I need to find the height and do some comparing. I might end up with two triangles, so that's why I'm doing this. All right, so height equals adjacent, which is 7, sine angle, which is 48. Put that into my calculator, 7 sine 48, and I get 5.2. So H equals about 5.2. So the opposite was greater than the height, but it was less than the adjacent. So that's that special ambiguous case. The opposite was greater than the height, but less than the adjacent, which means this side is long enough that it can hinge past that height there, but it's still shorter than the adjacent side. So we will be creating two triangles here. There's going to be the larger one that we had originally had drawn, and then there's also going to be this option. I'll draw it kind of down here. So we'll still have 7 and 48 degrees, but now this 6 is going to hinge inward instead of outward and create this kind of smaller triangle with an obtuse angle in it. All right. So we're going to use the law of sines to find both triangles. The first one I'm going to do sine of angle, which is 48, over opposite side, which is 6, equals sine of another angle. I don't have another angle, so I'll just call that B, because it's opposite the 7, over opposite side, which is 7. So I want you guys to pause the video and cross multiply and solve for B right now, and when you unpause, I'll have the answer for it. So I got that B equals 60.1. Once you have B, so that's going to be 60.1, you can use that to find the third angle. So 180 minus 60.1 minus 48 leaves us with an angle C of 71.9. Now that we have that other angle C, 71.9, we can use that to find the opposite side using law of sines again. I'm going to use sine 48 over 6 again, sine of angle over opposite side, but this time I'm using sine of 71.9 to find side C. So again, pause the video and actually work this one out on your own, and when you are done, unpause and I'll have the answer. Alright, so I got that little c equals 7.7. So this side length is 7.7. Alright, so that was all the solutions to the first triangle, but remember, we can also have a different angle for B, since we have two different triangles for this one. The first B was 60.1. To find the second B, we do, so B prime is going to be 180 minus 60.1. Oops. Sorry, my thing keeps glitching on me. And B prime is going to be 119.9. And we'll use that, and we'll use law of sines to find our B, our little b. Oh wait, never mind. We don't need to. What was I thinking? So that's what big B is, 119.9. And then we're going to use that to find angle C prime. So we'll do 180 minus the 48 minus 119.9. And we get that C prime is 12.1. Tiny little angle there. I should be putting my angle signs for both of them. Now using that C prime, I can finally find side C prime, little c. So we'll do sine of 48 over opposite side, which is 6, equals sine of 12.1 over opposite side, which we don't know. We'll just call that little c prime. Cross multiply, we get little c prime, sine 48 equals 6 sine 12.1. Divide both sides by sine 48. So type into your calculator 6 sine 12.1. Divide that by sine 48. And we end up getting little c prime is tiny, tiny. It's just 1.7-ish. So that's that right there. Alright, I think that is it for today. So what you guys really want to focus on is understanding all of these different cases. And really, the main thing you need to know is when you're going to have two triangles. So memorize if the opposite is greater than the hypotenuse, but also less than the adjacent, you're going to have two triangles. Alright, that's it. Thank you guys. Have a good one.